When you're problem solving in physics, there are set steps you must follow. These steps are not random. They're really meant to give you structure so that you can do any problem that you come across. When problems are easy, the tendency is for us to take shortcuts, not draw a sketch, not show the equation we're using, and really go through a problem without any structure and that doesn't communicate well, just to get to the answer. But in physics, it's the work that actually matters. The answer is actually the very smallest part of the process of problem solving. So we're going to take you through the list of requirements for solving any problem in physics. And you are not allowed to skip the steps because the answer, again, is the least of the issues. So we must see evidence of your thinking. So you have to have a setup, right? And I'll explain what that's about. You must show the equation you're using. You're just copying that from your equation sheet generally. You must show what numbers you're putting in, and you have to have answers with units. Right? So those are the 4 general requirements, and we'll talk specifically about what's required for each one. I don't really need to see your algebra work. If you want to do your algebra on, and just do your math on your calculator, that's fine. You want to work vertically down your page. Don't try to conserve space. It'll only make you make mistakes, honestly. And if you need more space on a test or a quiz or a checkpoint or on your homework page, just take another piece of paper and just label clearly, continue on the next page. So those things I want you to keep in mind. This is the rubric that we use for scoring a problem, and you cannot get a 3 unless you do a 1 and a 2. So these requirements are not repeated and these build on each other. So you may only at this point be down here and gradually over time you're going to work your way up. We want you to get to a 4 and then to a 5 eventually, if possible, right? You can see this is perfection. And it's really hard to be perfect. So that's not our expectation. Our expectation is about learning and growing. So we're going to go through the details of what you're required to do, and you're going to see how the levels build on each other. So first step is you at least attempt to solve the problem. You're not leaving a blank space. You're choosing an equation and you're showing some work written out. But it may be really disorganized. It may be the wrong solution entirely, but at least you're making the attempt. So in a level 2, you're attempting the problem, but now your work could produce a correct answer if you followed it through. It's relevant to the question being asked, and I can follow it. It's presented in a logical, systematic manner. Now level 3 is building on that. Now you've got a clearly labeled illustration. If required, you have a motion diagram and free body diagram. You have your vertical progression of your work. You're writing out the equation. You're rewriting the equation with the numbers plugged in. You show an answer. Again, there's nothing here about it being perfect, about being correct, or about being complete. But you're showing that you understand those steps that are required for problem solving. Now at a level 4 is here where your illustration has all the givens and unknowns showed at the appropriate places, or you've constructed some sort of table to organize it. You've got a correct motion diagram or free body diagram when they're necessary. You have the correct equation or equations. Your algebra is correct. You're showing the correct units on your answer. You might have a careless math or calculator error, but otherwise everything else is perfect. So you're really I'm going to be looking for everything is right, but maybe of a careless mistake, but not a systematic error. So, and I can find that error without any strain or stress because your work is so organized. And a 5 is really there's 2 options. Either it's everything is right, even your calculator work, or it's a problem you haven't seen before and you use all those steps even if it doesn't lead to a solution. And that's it. So make sure you're trying out these steps even when the problem is easy. Especially when the problem is easy, you should always take the time to do it because that's how you learn and grow. You're going to practice when it's easy so that they become automatic steps when something is hard.